All right, so we are looking at this element, K, or this molecule, excuse me, with potassium and oxygen. So I'm going to go look on the periodic table, and I see that potassium is in group 1, and oxygen is in group 16. So then if we look at which type of bond we're looking at, there's no hydrogen involved. So we go over here. Are the elements from group 1 or 2? The answer is yes, because of potassium. So that means we're going to have an ionic bond. So that's our bond type, and then we need to Lewis dot structures for 2 potassium atoms and 1 oxygen atom. You can see that because potassium is in group 1, it's going to have just 1 valence electron on each potassium, and then oxygen is in group 16, and so that means it's going to have 6. So after we got our valence electrons positioned, 3, 4, 5, and 6, then we'll be able to draw some arrows to show where the electrons move from and where they move to, because ionic bonds have arrows. And so this electron from the potassium is going to fill in the spot on the left side of the oxygen. This will fill in the spot on the right, or the bottom side. And so then what we have is an oxygen atom with 8 total valence electrons. And then 2 potassium atoms with no valence electrons. And so because these electrons moved, we need to show that the charges are now different. So the oxygen got 2 extra electrons, which give it 2 extra negative charges. Each potassium only lost 1 electron, so by losing an electron, the charge actually gets more positive. And that is the final Lewis dot structure for this molecule. Here we're just talking about oxygen, which is in group 16. So if we're talking about which type of bond, hydrogen is not involved, and there are no elements from group 1 or 2. So that means you've got a covalent bond here. You got 2 oxygen atoms, and because it's in group 16, that means each one has 6 valence electrons. Move these over, use a little bit more space. 5, 6, 1, 2, 3, 4, 5, and 6. Now covalent bonds have circles, and so we have to look for pairs of electrons that can bond between these atoms and be shared. And then what we need to do in our final drawing is replace those red circles with lines. So because I have two circles that are connecting these oxygen atoms, I'm going to have two lines in my final Lewis dot structure. And then any electrons that aren't inside of a red circle, we're going to show on the atom that they're on. So each oxygen atom has four. They're like this. And that's your final Lewis dot structure for there. In this molecule, we're considering hydrogen, which is in the top left corner, and nitrogen in group 15. So when we ask ourselves which type of bond is it, does it have hydrogen? And the answer is yes. So since it does have hydrogen, it's automatically going to be a covalent bond. We never have to even answer this question. So the type is covalent. And then here we're going to have one nitrogen atom. And this 3 means that there are 3 hydrogen atoms. So since nitrogen is in group 15, I'm going to have 5 valence electrons. And hydrogen is in group 1, so it has just 1 valence electron on each atom. Since this is covalent, we need to circle electrons that can pair. We're not going to circle these two because there's already 2 on that side of the nitrogen. We're looking for sides of atoms with just 1 valence electron. I apologize. So you can repeat that process for this bottom pair of electrons and this pair on the right. And then you can replace those red circles with lines. See that everything connects to my nitrogen atom. And so I'm going to put that in the middle. And then I'm going to make a red line 1H. Make a red line to another H. And then since we have to connect it to the nitrogen, this last H, I'm going to make a line downward to connect to that last H. All of the electrons that are on the hydrogen atoms are inside of red circles, so we don't have to represent them in our final. The nitrogen has 2 electrons that are outside. So that's our final Lewis dot structure for this molecule. The last one we're going to look at today is with magnesium and oxygen. So magnesium is in group 2, and oxygen is in group 16. So when we ask what type is it, is hydrogen involved? And the answer is no, neither of these is hydrogen. So I'm going to ask this question. Are there elements from group 1 or 2? And the answer is yes, because of magnesium. So because there is a group 2 element, we're going to be drawing an ionic bond. This ionic bond will have 1 magnesium atom and 1 oxygen atom. Again, magnesium is in group 2, which means that it will have 2 valence electrons, and oxygen is in group 16, so it'll have 6. Then with an ionic bond, we have to show arrows. So this electron is going to jump off the magnesium because oxygen is so close to having a full outer shell. This magnesium electron will also jump and fill the other spot. So that oxygen will finish with 8 electrons in its outer shell, which is a full shell. So I'm going to redraw my atoms. Oxygen now has 8. Magnesium has an empty outer shell, at least according to this Lewis dot structure. And so then we have to write down what charges they have. And so the oxygen got 2 extra negative charges, so it has a charge of -2. And then magnesium lost 2 negative charges, and so for every electron it loses, it gains a positive charge. And so we got this positive and this negative, and they are attracted together to make this bond.